Good morning, class. Today we're going to be looking at lesson number 9. Here we're going to start looking at the history of Earth's climate. And I thought a good way to start would be looking at how life on Earth started and periods in time where life really took off and periods of time where life didn't really do much. So if we look at the diagram here, there's a couple really interesting points to start. So life on Earth starts 4.6 billion years ago. Now, they use the terminology GA. So GA just means billion years ago. So they have 4,550,000,000 years ago is when Earth started. There's not really consensus on how accurate that number is. So generally we'll just say 4.5 billion years ago is when Earth formed. And when Earth formed, it was just a molten ball of rock. And then you can see they have a time frame for when the moon started forming. Again, I don't know how accurate these values are. I'll turn my video here. But that's kind of close, about 20 million years after the Earth really could be defined as formed. It collided with another planet, forming the moon. And then we move on to 4 billion years ago, and this is the end of the late heavy bombardment. So at this point in time, the solar system, at the end of the late heavy bombardment, the solar system had calmed down. The planets were where they should be. Jupiter has done its job and swept away any extra asteroids or meteors, and Earth fell into a calmer state. A lot less asteroids were hitting Earth. Earth started to cool down, so the crust of Earth started to form, and we got the first tectonic plates forming at about 4 billion years ago. Now, it wasn't really until 32 billion or 3.2 billion years ago that Earth really starts to become, what's the word? When Earth starts calming down entirely. So from 4 billion years ago to 3.2 billion years ago, Earth was still changing a lot. The plate tectonics were still forming. There was still a ton of volcanic activity that was constantly changing how the plates looked and the configuration of the plates. And Earth's surface was still very hot, and the atmosphere on Earth was incredibly hot compared to how it is nowadays. Then we get to 3.2 billion years ago, and this is where we are really first able to find information about the history of Earth's climate or life on Earth. We can predict that life started earlier. So here it predicts life starts 4 billion years ago, but it wasn't until 3.2 billion years ago that we could see any sort of actual information, actual data for how Earth looked. Everything before 3.2 billion years ago is all just theoretical information. It's all just a theoretical experiment. We don't really know, but based on how science works, we can predict what should happen, but we don't have any actual evidence that this happened. Although in the past, theoretical predictions and experiments have been incredibly accurate because we know the science so well that we can actually predict what's going to happen without actually knowing. But we don't actually have the actual evidence to confirm. But it's fair to say that this is pretty close to what it would have looked like. Okay, so moving on, if we look at the time period, we can go down to 3.2 billion years ago. And here's where the atmosphere really changed. And it was a really interesting change that occurred, and we'll talk about it in more detail next class. But the change in the atmosphere led to Earth becoming a snowball. So we call snowball Earth is when the whole Earth pretty much froze. So the entire Earth froze over, which is pretty crazy to think that like near the equator was just completely frozen, just like the North or Southern Pole. And then moving on, life starts to develop a little bit around 2 billion years ago. We start to get some multicellular life around 1.5 billion years ago. But it wasn't really until just maybe 800 million years ago that we got actual definitive life forming. And these were we had the first animals, which started in the ocean as fish. And then you can see here we got another snowball Earth. So Earth's climate can change drastically. Went from not being a snowball, being very hot, to being very cold, being very hot again, very cold again. And these are more drastic changes than like the Ice Age. The Ice Age, the planet cools, but with snowball Earth, the whole planet is entirely frozen. And then we look further in time, and we can look at see this very small dot here. This is where humans, or relatively humans, started to evolve. It's a very small portion of Earth's history. So I know we're not on astronomy anymore, but if we're looking at alien life and planets, and we're trying to look for alien life, and let's say we're looking at Earth. If you look at Earth at any point in its history, there's a massive chance you're going to find Earth with no intelligent life. You may find dinosaurs, you may find just single cellular life. The chance of you finding humans on it is very small. So if we're looking for aliens out there, the chance of it just being bacteria is way more likely than it being intelligent life, based on what we know from Earth, that most of Earth's history has not been dominated by humans. Okay, sorry for that side note there.